Today we can see the methods for the qualitative analysis of different elements present in an organic compound. How can you detect different elements present in an organic compound? That is a topic that we are going to discuss today. First, detection of carbon and hydrogen. Carbon in an organic compound can be converted to carbon dioxide. Carbon dioxide turns lime water milky. Similarly, hydrogen in an organic compound can be converted to H2O. H2O turns anhydrous copper sulfate blue. It is a basic principle that we are using to identify the presence of carbon and hydrogen. Carbon and hydrogen detected by heating the compound with the copper 2 oxide, cupric oxide. Carbon present in the compound is oxidized to carbon dioxide and hydrogen to water. It is allowed to pass through copper sulfate containing tube, and due to the presence of water, it will change into blue color. If the tube is changing to blue color, the presence of water is confirmed. And again, the remaining gases will pass into lime water. If lime water turns milky, it is very clear that gas contains carbon dioxide. So when carbon is treated with cupric oxide, carbon dioxide is formed, and when hydrogen is treated with cupric oxide, H2O is formed. CO2 plus COOH2 it is lime water, calcium hydroxide solution. Forms calcium carbonate, which is white in color, insoluble. So lime water turns milky. CuSO4 white in color, anhydrous CuSO4. When water, it combines with water, it will change it to CuSO4 5H2O blue in color. Now for the determination of or to detect the presence of other elements in the compound, we have to convert the organic compound, the different elements in the organic compound to ionic compound. Otherwise, it is very difficult to identify their presence. And that is done in the Lassanis test. In Lassanis test, first we have to prepare Lassanis extract or sodium fusion extract. In a fusion tube, that is a very small tube, organic compound is taken and the metallic sodium is added to it. Metallic sodium, you have to add metallic sodium into it and heat it to fuse until the fusion tube becomes red hot. And during the time of fusion, the elements present in the organic compound will combine with metallic sodium to form ionic compounds. And from that tube, by dipping it in distilled water, we can extract the compounds formed. Extract the compound formed using distilled water. You dip the red hot fusion tube into the water. That will break and the condensed will dissolve in water. Boil again to dissolve completely. Then filter it. After removing all the solid substances, you will get a clear filtrate. That is sodium fusion extract or Lassanis extract. In Lassanis extract, if carbon and nitrogen is present, that will combine with the sodium to form sodium cyanide. If nitrogen is present, there will be sodium cyanide. If sulfur is present, that will combine with the sodium to form sodium sulfide, Na2S. If halogens are present, that will combine with the sodium to form sodium halide. For example, sodium chloride, NaCl, sodium bromide, NaBr, and sodium iodide, NaI. If carbon, nitrogen, and sulfur, these three are present together, then sodium will combine with these three to form sodium thiocyanate, NaSCN, sodium thiocyanate. Okay, now the elements in the organic compound is converted to ionic compound, sodium cyanide, sodium sulfide, sodium halide. Ionic compounds, they are converted to ionic compounds. Okay, now the estimation of, analysis for nitrogen, test for nitrogen. Take sodium fusion extract and heat it with the iron 2 sulfate, that means FeSO4, ferrous sulfate, and then acidify with concentrated sulfuric acid. If you are getting a Prussian blue color, indicates the presence of nitrogen. The sodium cyanide will react with Fe2 plus to form FeCN 6 times 4 minus. FeCN 6 times 4 minus will combine with Fe3 plus. In FeSO4, there will be Fe3 plus also because of the oxidation of FeSO4. That Fe3 plus ions will combine with FeCN 6 times 4 minus to form Fe4 FeCN 6 times thrice XH2O, that is Prussian blue colored compound. Its name is ferric ferrocyanide. Ferric ferrocyanide. So the Prussian blue color is due to the formation of ferric ferrocyanide. Okay, now test for sulfur. If sulfur is present, take sodium fusion extract, acidify to the acetic acid, then add lead acetate solution to it. When you add lead acetate, it will react with the sulfur in sodium sulfide to form lead sulfide, which is black in color. So you can see the formation of black precipitate. If there is sulfur, you will get the black precipitate of lead sulfide. So that black precipitate indicates presence of sulfur. Or we can use another reagent to test the presence of sulfur. That is sodium nitroprusside. So sodium fusion extract is treated with the sodium nitroprusside. Appearance of a violet color indicates the presence of sulfur. Why there is a violet color? That is due to the formation of FeCN 5 times NOS4 minus, which is violet in color. Formation of a complex FeCN 5 times NOS4 minus. What is sodium nitroprusside? FeCN 5 times NO, 2 negative. That is the formula of sodium nitroprusside, and if there is sulfur, that also will enter into the coordination sphere to form FeCN 5 times NOS 4 minus. I already told you, if nitrogen and sulfur present together, sodium will form sodium thiocyanate. Na+C+, Na+C+, N plus S gives NaSCN. NaSCN react readily with Fe3 plus ions to form ferric thiocyanate, which is blood red in color. So that you can check by adding ferric salt. For example, ferric chloride. Add 1 drop of ferric chloride to it. Then what happens? You will get a blood red coloration that indicates presence of nitrogen and sulfur together in the organic compound. Okay, now the test for halogens. In order to test the presence of halogens, sodium fusion extract is treated with the dilute HNO3 and silver nitrate is added. Sodium fusion extract is treated with nitric acid, dilute nitric acid, and silver nitrate solution is added. If you are getting a white precipitate which is insoluble in ammonium hydroxide, indicates presence of chlorine. Pale yellow precipitate partially soluble in ammonium hydroxide indicates the presence of bromine. Yellow precipitate insoluble in ammonium hydroxide indicates the presence of iodine. Here actually what is the reaction? The halide or chloride, bromide or iodide that will react with Ag plus in AgNO3 to form silver halide, like silver chloride, silver bromide or silver iodide. That is the reaction taking place here. Next, test for phosphorus. Here we are not using the sodium fusion extract directly. The organic compound, we will take the organic compound. Organic compound is heated with sodium peroxide or fuming nitric acid can be used. Then the phosphorus present in the compound will be converted to phosphoric acid. That phosphoric acid, when treated with ammonium molybdate, it will form yellow colored ammonium phosphomolybdate. That yellow color indicates the presence of phosphorus. So what is the test? Heat organic compound with the sodium peroxide or fuming nitric acid, then add ammonium molybdate to it. If you are getting yellow precipitate, that indicates presence of phosphorus. And that yellow color is due to the formation of ammonium phosphomolybdate. It is the formula of ammonium phosphomolybdate. NH4 thrice PO4 12 MoO3. NH4 thrice PO4 12 MoO3. Quantitative analysis. I think we can see it in another class, and we can stop it here.